All right, so today I'm going to talk about a little bit of chemistry. So you got ions and then ionic bonds. So with ionic bonds, it's just literally going to be a transfer of electrons from a metal to a non-metal. So with that, that's going to create an ion. You're going to get positively charged ion, which is called a cation. So it's always, or typically, is going to be a metal, and then you get a negatively charged anion, and then typically they're going to be the non-metal. So basically, what happens is the metal is going to be donating an electron to the non-metal. So every time you form what's called an ionic bond, again, an ionic bond is going to be a bond between a metal and a non-metal. Anytime you form an ionic bond, you're going to create a salt. So here what you're looking at, I have the sodium atom. So this entire thing is the sodium atom. And then this entire thing over here is the chlorine atom. So you're looking at its electrons. You're looking at all the different electron shells. And the one that you really need to pay attention to is what they call the valence electron, or the outermost shells. Yeah, and then you can see that's this one that I have here in red. So if we count all the electrons here inside of sodium, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's why it has 11 protons and then 11 electrons. And then you come over here to the chlorine atom. You can do the same thing and count them, and you'll have 17 electrons. All the electrons are here, what you have in blue. So you could count them. You'd have 17 protons and then 17 electrons in the shells. The reason why you see these shells is because this is where the electrons are orbiting around the actual atom or around the nucleus. So what you can see for this interaction to take place, what's happening in sodium over here is the metal. Chlorine is the nonmetal. So like I said, in order to form an ionic bond, you're going to get the transfer of an electron from a metal to a nonmetal. So here you're seeing this red electron coming from the outermost valence shell of sodium to satisfy chlorine's outermost shell. So you want to have 8 in the outermost shell. It's the octet rule. So what's going to happen is it's easier for sodium to donate this one electron over here to chlorine than it would be for it to get 7 electrons. So you see it only having one electron in its outermost shell. In order for it to satisfy this octet, it would have to receive 7. So it's easier for it to just give this one up, and then it's going to be satisfied. So here what you're looking at, this is the interaction continued. So what we saw is we saw this outermost electron shell, or what they call the valence shell. We saw this outermost electron get donated. So you lose that outermost shell, and see now, look, that sodium is now satisfied. It's got 2 electrons, 4, 6, 8 in its outermost shell. So it gave up that one, and now it has 8 in its outermost shell in the next shell. So when you look over here at chlorine, you can count it. It now has 2, 4, 6, 8. So here chlorine is now satisfied with 8 in its outermost shell. What this atom is now called is it's now called the chloride anion, because now we've created ions. We have the positively charged sodium. Here you can see this cation here. And then you can see the chloride anion. The reason it's becoming negatively charged is because you just passed an electron to there. This sodium just gave up an electron. So because you gave up something that makes you more negative, you become more positive. So now we have 10 electrons and 11 protons. Over here with the chloride anion, you now have 18 electrons and 17 protons. So here you're now able to see that they have this interaction, because you've now created something that's positively charged and then something that's negatively charged. Again, it's the sodium cation and then the chloride anion. So now they're actually able to have an interaction between their outermost valence shells through these electrons that they're transferring. So you can see that you create what's called sodium chloride, and which is just basically table salt. So every time that you have an ionic bond, you're going to create a table salt. Or I'm sorry, you're going to create a salt.